Hello, welcome to the video. In this section, we're looking at 1.4, where we're going to look at perimeter and area in the coordinate plane. So we're going to figure out how you can find the perimeter and area of a polygon in a coordinate plane. So for starters, we have to figure out what is a polygon. A polygon in geometry is a figure that lies in a plane uh, called a plane figure. Recall that a polygon is a closed plane figure formed by three or more line segments called sides. Each side intersects at exactly two sides, one at each vertex, so that no two sides with a common vertex are collinear. You can name a polygon by listing the vertices in consecutive order. So looking at the diagram on the right, each vertex is labeled, so they're denoted as points. So, B is a point, A, C, D, E, those are all points. Each point is called a vertex. Each line segment that's connected to those vertexes are called sides, and we can go from there. There are two different kinds of polygons. You could have what is called a convex polygon, or you can have a concave polygon. So how I show it or how I illustrate it is you can use like a straight edge, like your textbook, your pencil, and what you're going to do is this, is if you identify that your pencil, your straight edge, or whatever intersects the interior of that polygon, and it only has to occur on one line segment, that it is automatically concave. It'll automatically be concave. So just remember that concave means intersection of interior. If you check every single side of a polygon and it does not intersect, then it's going to be convex. So like if you look at example A, all right, if I went and put my straight edge here, it doesn't intersect. But if I go onto this side, oh look, here's the intersection. It only has to occur in one line segment, so this particular polygon is concave. Looking at B, I can go, okay, nothing intersects with that one. Nothing intersects the interior here. Nothing intersects the interior here, or here, or here, or here. So it didn't intersect the interior at any point that I drew it over those sides. This would be an example of a convex polygon. So again, I would ask you to give this a try. In this one here, they say classify the polygon by the number of sides. So like here, this is 1, 2, 3, 4, 5. A five-sided polygon is a pentagon. Here, this one is a 1, 2, 3, 4, 5, 6, 7. That's 7. So 7 sides is a heptagon. And 1 is a concave, 2 is a convex polygon. So here they're asking us to find the perimeter of triangle ABC with vertices located at those coordinate points. So anytime you're looking at perimeter and when you're looking at a triangle, for instance, perimeter of a triangle is just going to be the measurement of A plus the measurement of B plus the measurement of C. So like whatever, since there's three sides, whatever the first measurement is plus the second measurement plus the third. So let's take a look. So A, they said, is negative 2, 3. So that's A. I'm just going to put negative 2, 3 right there. B is at 3 comma negative 3. Oh, that doesn't work. 3 comma negative 3, which is right there. So that's B. And C is at negative 2 comma negative 3. So A, B, and C. So this is the triangle. All right, so what makes this one not too bad is we can count two of the sides because they're right along here. So I can say that like BC is at 1, 2, 3, 4, 5. So that's 5. And AC is at 1, 2, 3, 4, 5, 6. So that's 6. The one that's a little bit more tougher to find is line segment AB. So in order to do that, we have to resort back to our resources from previous section and implement the distance formula. So remember that distance formula was x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And again, you just pick whatever value you want for your x1, y1, and your x2, y2. So I'm just going to pick point A as my x1, y1, and B is my x2, y2. So my distance, so I'm going to say that AB will be equal to, and x2 is what, 3 minus a negative 2 quantity squared plus y2, which is negative 3 minus 3 quantity squared. Now this portion here, this 3 minus negative 2 is a cross line change sign situation, so I'm going to take care of that. 3 plus 2, 5, 5 squared. It's 25, so I got the square root of 25 plus negative 3 minus 3, which is negative 6, square that, which is 36. So 25 plus 36 equals, what, 61. So I got the square root of 61. And I will just give it an approximate value. Square root of 61 is about 7, we'll say 7.8. So this is 7.8. So to find the perimeter of this, it is going to be that 7.8, which we found, plus 5 plus 6. So 7.8 plus 5 plus 6 gives us a perimeter of 18.8 units. Here, they want us to find the area of triangle DEF with these vertices. So, if you don't remember, area of a triangle is 1/2 base times the height. So, again, let's plot the points. So D is at 1, 3. E is at 4. 1, 2, 3, 4, negative 3. 1, 2, 3. So that's E, which is 4 comma negative 3. And F is at negative 4. 1, 2, 3, negative 4, negative 1, 2, 3. So it looks like, yeah, that's F. And what you should do is make sure you choose your base and your height to make it, as easy on yourself as possible. Could you choose any one of your bases? Sure. But I wouldn't choose like DE as my base because it's not that side measurement's not easily discovered unless I use the distance formula. The easiest one to discover the base is EF right here, and that is a distance of 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. And I can easily find the height because the height is going to be a measurement from the opposite vertex, and it is perpendicular to the base. And in this case here, I have a height of 1, 2, 3, 4, 5, 6. So my height is 6. So, you know, in this particular instance, it wasn't um, as labor intensive to find the base and the height, and I can just plug it in the formula. So it's going to be 1/2 times it by the base, which is 8, times it by the height, which is 6. So multiply all those out, 1/2 times 8 times 6 gets us a value of 24, and since it's area, it's going to be square units. Finally, here it says you are building a shed in your backyard. The diagram shows 4 vertices of the shed, so it looks like it's got 2, 7, 8, 7, 2, 2, and 8, 2, respectively with G, H, K, and J. Find the area of the floor of the shed. So it's a rectangle. Rectangle measurement is length times width. We'll call this the length right here. It is at 1, 2, 3, 4, 5, so it's at 5. The width is at 1, 2, 3, 4, 5, 6. So we can say this is 5 times 6, which means we have an area of 30 square units. And that is being able to find perimeter and area in coordinate planes. Hope this helps. Till next time.